All right, good morning, folks. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we wrapped up Chapter 2 and we finished talking about solving linear inequalities. In this video, we are going to begin Chapter 3, and we're going to talk about linear equations, but they're not going to be the exact same linear equations as we saw in Chapter 2. We're going to be a little bit different, and we're going to introduce some new concepts. For some of us, this may be stuff we had all seen in the past, so it's not completely brand new, but in terms of where we are in the course so far, it is new. So up until now, we've worked with linear equations in one variable. So let's look at something now that's a little bit more involved. Linear equations in two variables. A linear equation in two variables, and commonly we see x and y being used. You don't have to use x and y, but typically that's what we use. So a linear equation in two variables, commonly x and y, is an equation that can be written in the form below. A times x plus b times y is equal to c. A, b, and c are all real numbers. And a and b are not both 0 at the same time. And when you have an equation, a linear equation in two variables in this form, this is referred to as standard form. Just like the statement of a linear equation in one variable, not all linear equations in two variables may be handed to you in this form, but the fact that it can be written in this form is what makes it a linear equation in two variables. So here are some samples. 5x minus y is equal to 7. That is already in that form. 2x minus 4 is equal to y. Not exactly in this form here, but if we just move a couple terms, then we can put it in that form. And then x equals negative 5 times y minus 1. Again, just moving of some terms will get it in this form. So these are all examples of linear equations in two variables. When we talked about linear equations in one variable, we talked about solutions to them, and we started off easy, where we were given a value that could potentially be a solution, and we had to see if it was or not. So for linear equations in one variable, we saw that a solution to the equation was a single number that replaced the one variable that we had. Again, typically x, could be t, could really be whatever. But now for linear equations in two variables, we can't just work with a single number to represent just one variable because we have this other unknown quantity here. So we need two numbers to make a solution, one number for each variable. The numbers could be the same for each variable, but we need a specific number for x and a specific number for y. And how do we represent this solution? We write these numbers inside parentheses and separate them with a comma. And in this context, this is referred to as an ordered pair. Some of us may have heard that two-word phrase before. The first number that's written is always the x value, the number that you're substituting in for x, and the second number is always going to be the y value, the number that you're substituting in for y. So this whole thing is an ordered pair. You have two numbers, x comma y, inside of parentheses. So we'll start off easy, start off slow. We're going to check that the given ordered pair is a solution to the given linear equation in two variables. We'll check to see if it is or if it is not. So 5x plus y equals 13, and our ordered pair is 2 comma 3. So once again, the first number written is always for x. The second number that's written is always for y. So I'm going to have this 2 take the place of the x. I'm going to have this 3 take the place of my y. And we'll see if we get the left and right hand sides to be equal. So 5 times 2 plus 3. Again, putting that question mark over the equal sign because we're not sure if this is equal. Well, I think probably didn't take us too long to figure out that 5 times 2 is 10, plus 3 is 13, is indeed equal to 13. So yes, this is a solution to this linear equation in 2 variables. Okay, let's try this one here. Negative 2x minus 3y is equal to positive 4. And our ordered pair is 1, negative 2. We'll see if this is a solution to our given linear equation. So again, x, y, and you make your substitutions. I have negative 2 times my x value of 1 minus 3 times my y value of negative 2. And is this equal to 4? Well, let's do the multiplication and then the combination and see what our order of operations gives us. Negative 2 times 1 is negative 2. Then we have minus a 3 times a negative 2. So minus a negative 6. Is this equal to a positive 4? Well, recall that minus the minus, those combine and become pluses. So I have negative 2 plus 6, which is 4. And obviously, 4 is indeed equal to 4. So this is verified. These two sides do equal. And this is indeed a solution to this linear equation in 2 variables. So really easy, really straightforward. Take the first number that's listed, plug it in for x. Take the second number that's listed, plug it in for y. Now, we can find a missing component to an ordered pair that would make our linear equation true. If you're given the linear equation and you know one of the 2 values, then you can find the missing value. What you do is you substitute in the value that you know, and then you simplify that, and you're going to get now a linear equation in 1 variable. We know how to solve linear equations in 1 variable, and we solve for the 1 variable that we have left, and that value would fill in the blank, fill in what you're missing. So we're going to complete the ordered pair that is a solution to the given linear equation. So first one, 2x plus 5y is equal to 17. And I know that the x value in my ordered pair, the x value in my solution, is going to be 4. So I know that if I plug in 4 for x, I need to come up with the y value such that this is going to be true. So if I do 2 times 4 plus 5y, well, that's going to give me 8 plus 5y is equal to 17. And then now we're down to solving a linear equation in 1 variable now. So if you subtract the 8 from both sides, 5y is equal to 9. And that means y is equal to 9 over 5. So the missing value is 9/5, or 9/5. And our ordered pair is 4, 9/5. Moving on to our next one here, negative x minus 6y is equal to positive 1. And I know that in my ordered pair, in my solution, my y value is going to be 3. So let's make that substitution. And when we do that, we'll get a linear equation now in one variable. If I substitute 3 in for y, and I do minus 6 times 3, that's going to give me minus 18. And that gives us negative x minus 18 is equal to positive 1. All right. Now, again, I want to get x by itself when this is all said and done. So I'm going to add 18 onto both sides to give me negative x equals 19. And then I'm going to divide both sides by the negative 1 to just get x. So x is equal to negative 19. And there we go. That's the missing value in my ordered pair. My solution, my ordered pair, is going to be negative 19, 3. We'll do the third one. I'll let you try the fourth one on your own. So once more, negative 5x minus 4y is equal to a negative 5. And I know that my x value has to be 1. So if I make that substitution, I get negative 5 times 1, which as we know is negative 5, minus 4y is equal to negative 5. I need to find what my y value is. I need to get the y all by itself. So I'm going to kick it off by adding 5 to both sides. And that's going to give me negative 4 times y is equal to 0. And then if you divide both sides by the negative 4, you find that y is equal to 0. So there is our missing y value. There's the missing value in this ordered pair. And our ordered pair is 1, 0. So as I said, I'll let you try the fourth one on your own. We'll go through that guy in class. So up until this point, we've just been working with one particular ordered pair, one x value and one y value. Well, later on in this chapter, we are going to see that to do what we want to do, we need to know more than one ordered pair that makes a linear equation in two variables true. And it's common to write more than one ordered pair for this type of linear equation in a table of values. This, as I would guess, is probably not going to be brand new for many of us, if any of us. We have two columns. They're labeled x and y up at the top. And then you have some x values and some corresponding y values. And the idea is that when you take the x and the y value in the same row and you substitute them into your linear equation in two variables, like I have here, then that x value and that y value are going to make the equation true. So if you take 0 and plug in for x and take 10 and plug it in for y, that's going to make this equation right here true. Similarly, if you plug 1 in for x and 7 in for y, that's going to make this guy true. If you plug 2 in for x and 4 in for y, it's going to make this true. And if you plug 3 in for x and 1 in for y, that's going to make this true as well. And we can do this with any x value whatsoever, and then you would have the y value that would work as well. Or it can go the other way. You can have, say, a y value and then find the x value that's going to work with it as well. So we can fill in a table of values with the missing numbers as long as we're given the linear equation and we know one of the numbers, just like we did with the previous few problems there. We're just going to take care of multiple and missing values sort of at once here. So we'll do a couple. I'll let you figure the rest out on your own. So we want to fill in the missing values for this linear equation here. 4x plus 3y is equal to 24. Let's fill in the first two blocks or blanks, and I'll let you fill in the other three. So when x equals 0, I have 4 times 0, which as we know is 0. So I have 0 plus 3y, or 3y, is equal to 24. And I'm just going to label x equals 0 here so we know what this y value is going to correspond to. If 3 times y is equal to 24, divide both sides by 3, and you get y is equal to 8. All right, x equals 2. Again, substitute in 2 for x, and then we're going to solve for y once again. So 4 times 2 is 8, plus 3y equals 24. We're down to solving a linear equation in one variable. If I subtract 8 from both sides, y is equal to 16. And then if you divide both sides by 3, you get y equals 16 over 3. So I'll let you fill in the other 3 blanks in this table. And note in a couple cases you're going to have to substitute a value in for y, and then you're finding x. So guys, that concludes this video. We'll stop here for now. In the next video, we are going to finish up this section. We are going to talk about how can we visualize these solutions to linear equations in 2 variables. And we're going to talk about the Cartesian coordinate system and plotting points. If you have questions or comments, be sure to reach out to me, guys. Email, phone call, in-person visit in my office, flare signal sent up into the sky, whatever you have to do. Until the next video, take it easy, guys.